Hi students, warm greetings to you all. This is your maths mentor Valli. In this video we are going to see types of sets. First of all we can see empty set or null set. A set consisting of no element is called as empty set or null set or void set. Empty from the name empty, null itself you can understand about the characteristic of the empty set. It is denoted by phi, that is we read this as empty and the empty curly bracket. Example, the set of all integers between 1 and 2. There is no integer, obviously there is no integer between 1 and 2. So this is a example for null set. Second one, singleton set. From the name itself, single, that means consists of only one element. A set which has only one element is called as singleton set. Example, the set of all even prime numbers. We know that prime numbers are nothing but the numbers which are divisible by 1 and itself. The number 1 is neither prime nor composite. So the prime number starts from 2, 3, 5, 7, etc. The only prime number is 2. So we have given as an example for singleton set. Next one, finite set. From the name finite itself, if the numbers are countable, we can say that it is a finite. A set with a finite number of elements is called as finite set. Example, the set of family members. Of the families are countable. So it is infinite set. Next one is infinite set. A set which is not finite is called as infinite set. Example, the set of all points in a line. We can draw innumerable lines through a point. So it is an example for infinite set. Okay. Cardinal number of a set. Cardinal number of a set is nothing but number of elements in the set is called cardinal number. When a set is finite, it is very useful to know how many elements it has. So the number of elements in a set is called as cardinal number of a set and it is denoted by n of a. Now the cardinal number of a set is denoted by n of a. Now equivalence set. Two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written as A equivalent to B. We read this as A equivalent to B. If A and B are equivalent sets, then n of A equal to n of B. Next one, equal sets. Two sets are said to be equal if they contain exactly the same elements, otherwise they are said to be unequal. The elements also should be exactly the same, also the number of elements should also be the same. So this implies equal sets means every element of A is also an element of B. Likewise, every element of B is also an element of A. Now for example, set A equal to 1, 2, 3, 4, B equal to 4, 2, 3, 1. So here exactly the elements of A is present in the set B. So universal set. The universal set is a set which contains all the elements of all the sets under consideration and is usually denoted by U. For example, the set which contains all the elements of the set is under consideration. That means, see here, set of all natural numbers. Now this is the universal set for set of all even numbers and this is the universal set for set of all odd numbers. And subset, let A and B be two sets. If every element of A is also an element of B, then A is called a subset of B. So A contained in B. We read this as A is a subset of B. So the element 1 is a subset of set 1, 2, 3. And proper subset, if A and B are two sets, and if A is a subset of B and A not equal to B, then A is called the proper subset of B, and we write A is a proper subset of B. Here the elements of A is also an element of B, but here the condition is for proper subset A not equal to B. Example, set A equal to 1, 2, 3, set B equal to 1, 2, 3, 4, 5. Now A is a proper subset of B. See here, elements of A is also an element of B, but A not equal to B. So A is a proper subset of B. Exercise 1.2, find the cardinal number of the following set. Okay. Now the first sum is given as M. Set M equal to set P, Q, R, S, T, U. So cardinal number means, as we all know, that cardinal number of elements in a set. So 1, 2, 3, 4, 5, 6. So n of M is 6. Now second question is, set P equal to set of all x such that x equal to 3n plus 2, n belongs to W and x is less than 15. So there is a restriction for the value of x, that is less than 15. N belongs to W means n actually whole number starts from 0, 1, 2, 3, etc. So when n equal to 0, the value of x is 3 into 0 plus 2 equal to 2. N equal to 1, x equal to 3 into 1 plus 2, 5. So likewise, we have taken the value of n up to 4. Why? Because means this itself gives the value 3 into 4 plus 2, 14. So beyond this, if I substitute n equal to 5, it goes beyond 15. But the limitation is for x is 15. So we have to list out the elements 2, 5, 8, 11, 14. So number of elements in set P is 1, 2, 3, 4, 5. So n of P, always cardinal number is denoted by n of that particular set. So n of P equal to 5. Now third question, Q equal to set of all y such that y equal to 4 by 3n, n belongs to n and n is greater than 1, less than or equal to 5. So the value, the 5 is also included since equal to is there. So n belongs to n means there is a restriction for the value of n greater than 2, less than or equal. So 2, 3, 4, 5. So when n equal to 3, y value becomes 4 by 9. How means y 4 by 3 into 3. N equal to 4 means y equal to 4 by 3 into 4, 4 by 12. N equal to 5 means y equal to 4 by 3 into 5, 4 by 15. So the set Q consists of the elements 4 by 9, 4 by 12 and 4 by 15. So n of Q is 3. Fourth sum, set R equal to set of all x such that x is an integer, x belongs to Z and x is greater than or equal to minus 5 and less than 5. Greater than or equal to minus 5. So as we go through the right hand side, we get the increasing number, and when we move left side, we get the decreasing number. So the number which is greater than minus 5 means we have to go right side of the number line. So minus 5 is also included. Why? Because means equal to sign is there. Minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So how many elements? 10. So n of R is 10. So fifth sum, set S is given by the set of all leap years between 1882 and 1906. So we have to list out the leap year between these two years. Leap year means the year which is divisible by 4. It is divisible by only 4. Now when we divide this 1882 by 4. Why? Because means we are going to find out the leap year. 4 4s are 16, 4, 7 4s are 28, balance 2. Now if we want to find the next number which is divisible by 4 means you have to add 2. So that is 1884. So only I have started with 1884. 18 next plus 4. 1888 plus 4, 1892 plus 4, 1896 plus 4, 1900 plus 4, 1904. In this 900 is divisible by 4, not only by 4, it is also divisible by 4, it is also divisible by 400. Now the condition is for the leap year it should be only divisible by 4. So we have taken into account only these 5 years. So n of s is 5. Second question, identify the following sets as finite or infinite. First one, x equal to the set of all districts in Tamil Nadu. We can always list out all the districts in the Tamil Nadu. So it is finite. Second question, y equal to set of all straight lines passing through a point. Suppose if I draw a line means we can draw innumerable lines. So we cannot count it. So the set y is infinite. Third question is set A equal to set of all x such that x belongs to z and x is less than 5. So on a number line, if we want to get a number less than minus 5 means we go to the left hand side and it goes on. So it is infinite. Fourth sum, set B equal to set of all x such that x square minus 5x plus 6 equal to 0, x belongs to n. And it is a quadratic equation. Quadratic means it contains only 2 solutions, 3 and 2. So the value of x is only 3 and 2, so it is finite. Next sum, third sum. Which of the following sets are equivalent or unequal or equal sets? The first sum is set A equal to set of vowels in English alphabets. So vowels, as you all know, that A, E, I, O, U, n of A equal to 5. Next, set B is given as set of all letters in the word vowel. So we are going to write all the elements of the set B, V, O, W, E, L. There should not be any repetition. And as of now, here no repetition. So n of B equal to 5. First of all, we have to only, you can say whether it is equivalent or equal set only when the elements are listed out. Now n of A equal to n of B equal to 5. So they are equivalent sets. Now second sum, set C equal to 2, 3, 4, 5. Set D equal to set of all x such that x belongs to W, x is greater than 1, less than 5. So the number which is greater than 1 is 2, less than 5 is 4. So 2, 3, 4. Here n of C is 4, n of D is 3. So n of C not equal to n of D. So they are unequal sets. Third sum, set x equal to set of all x such that x is a letter in the word life. So L-I-F-E, n of x is 4. Now y equal to they themselves have given us F-I-L-E. So here also n of y equal to 4. Now here note that all the elements are exactly the elements from y. L, I, F, E. So they are equal sets. How means the elements are also exactly same. The number of elements are also same. So they are equal.